Hello everyone, welcome to the day 8 of the Machine Learning Teach by Doing project. In the previous two lectures, we have taken a look at linear classifiers and we have actually developed our first machine learning algorithm, which is the random linear classification algorithm. For executing that algorithm, we went through all of these 6 steps. In the part 1 of the lecture, we went through the steps on gathering our data, generating the linear hypothesis class, defining the loss function. And in the part 2 of the lecture, we went through the remaining 3 parts, which is finding the algorithm, running the algorithm, and validating the results. In today's lecture, what we will be doing is we will be coding the linear classifier in Python. Essentially, what we'll be doing is these 6 steps which you observed over here, we will be running the code in Python completely from scratch so that you will see a practical and a hands-on implementation of the theory which you learned in the previous lectures. As I mentioned, I want this course to be a mixture of theory plus practical. Last two lectures were devoted to theory, and this particular lecture will be diving into the practical aspects. So, other courses might just teach you just doing it in Python, but then you will miss out on the theoretical base which we have built up. So, today we will understand about coding linear classifiers in Python. The only background knowledge which I expect about Python is just installing Python in the first place. And I've already made a lecture for it. It's in day number 5. I show how to install Python and integrate it with VS Code in just 20 minutes. So if you have not seen that lecture or if you have not installed Python, then please watch it. It's barely 25 to 30 minutes lecture. If you have installed Python on your system, that's great. Then you don't need any prerequisite for following with me in this lecture. After making the content and after writing the notes, which as always I'll be sharing with you on in the YouTube information, I realized that I'll break this into 2 parts just because I don't want to make one video very long. So in the first part, what we will be learning is Jupyter notebooks and 3 powerful Python libraries. Overall, for the 2 part coding session which I have planned, we will be learning these 4 things. But in this video, we will look at number 1, what is Jupyter notebook? What why has it become so popular? What are the advantages of Jupyter notebooks? How to integrate Jupyter notebook with VS Code? And then we will also learn about libraries in Python. After installing Python, we will learn why Python has become so famous. And we will learn 3 of the most powerful libraries in Python. First is called as NumPy, second is called as scikit-learn, and third is called as matplotlib. After introducing these libraries and Jupyter Notebook, we will install these in the VS Code environment so that our Python installation is configured with these libraries and with the Jupyter Notebook environment. So let's get started. First, let me introduce Jupyter Notebooks. Jupyter Notebook, if you go to the documentation itself, Jupyter Notebooks are a community standard for communicating and performing interactive computing. Basically, the way I think about Jupyter Notebook is very much in the communication space. If you just write a code in VS Code, it is very difficult for you to communicate it with others because it's quite difficult to integrate the code with the title, description, etc. What Jupyter Notebook does is that in the Jupyter Notebook document, you can have a mixture of text, you can even add mathematics, images, videos, etc. along with the code. So basically, it makes it much easier to explain and go through the code. Overall, it's an amazing tool for communication, and that's the reason why I'll be showing the code through Jupyter Notebook, because it will be much easier for me to exactly show you guys how different lines of codes are working. An example of this is let us go below in this documentation. An example of this is this particular example. So the first way is to just write this in VS Code, but that's not good, right? In Jupyter Notebook, you can even write a title like this. You can write a description, then you can show the code cell, then you can show the plotting, then you can even write next steps, etc. I believe that this thing itself is written in Jupyter Notebook style. This document which I'm showing to you right now. So in a sense, this is much better for communicating codes, and that's why so many engineers and so many students use Jupyter Notebook for writing initial Python scripts, and many teachers around the world, such as myself, who are teaching machine learning, they really like Jupyter Notebook because it makes the teaching and the explanations much easier. So that's the first thing which we learned today, Jupyter Notebooks. I'll show you briefly how we can integrate it with VS Code. But before that, let me introduce the other three powerful Python libraries. The first library is NumPy. So if you go to numpy.org, that's the website. And the one sentence description of NumPy is that it's the fundamental package for scientific computing with Python. So NumPy allows us to define arrays, manipulate arrays, matrices. It gives several computing tools for linear algebra and for several other machine learning frameworks as well. And this library is fully open source, which means that it's available publicly on GitHub. Um, and so here you can see NumPy allows you to do different things. First, you have to tell the Python editor that you are loading this particular package, and once you do that, then later you can do several things. So here you can see that here we are creating a 2D array, and we are setting every second element in some rows and finding the maximum per row. Basically, some array operation is being performed here. NumPy makes it very easy to define arrays and perform mathematical operations. As you can see, there are several possible applications in even data science, machine learning, and visualizations. That's why NumPy has become extremely popular. In fact, if you go to the documentation section of NumPy, you will see several things about getting started, user guide, etc. But every single developer I know uses NumPy in some or the other code which they write. It's the default package which people go through for um, manipulating matrices, arrays, essentially anything related to scientific computing. Okay, so let me again go to the documentation, and let me show you the GitHub repository. So it's fully open source. Here you can see that it has 26,000 stars, 9.2 thousand forks, which means 9,000 people have forked this repository and tried to edit it on their own. So if someone is interested to check out NumPy code, please you can check it out at this GitHub repository. If not, it's perfectly fine. You just need to know that NumPy is used for scientific computing. I'll show you how it can be used in practice. Second package which is extremely powerful is scikit-learn, and this is a package which is very specific to machine learning in Python. Essentially, scikit-learn is a library which provides so many out-of-the-box functions which you can directly use for several tasks such as classification, regression, clustering, etc. The purpose of these libraries is that someone has already written down the library so that when you want to execute a famous ML algorithm, you don't have to write the entire code. You can just write the function which is provided by this particular library. In this case, scikit-learn. And scikit-learn is built on top of NumPy itself. So later we'll learn about all these things, classification, regression, clustering, etc. But for all of these machine learning tasks, scikit-learn essentially is the best library to do or to perform all of these ML tasks. And it's widely used in practice. The reason I'm demonstrating this library to you and the reason we are going to follow this is even if you are doing a simple project or a complex project, scikit-learn is the library which you will use. The third package which I want to show is a plotting library. It is called as matplotlib. Let's say you're running a Python script, and if you want to have plots for visualization, such as this particular plot, or let me see some examples. Or let's say you want to see a bar plot or a stacked bar chart or a grouped bar chart, or if you want to see some sort of an error plot like this, or if you want to see some sort of a histogram or density plot. How will you plot these in Python? Matplotlib is the library which you can use to plot all of these aspects. So it's an amazing tool which can be integrated with several different codes if you want to plot or show some visuals. We will be using all three libraries today. We will be using NumPy, we will be using scikit-learn, and we will also be using Matplotlib. Note that scikit-learn is built on top of NumPy and also Matplotlib. So these three are the extremely powerful Python libraries: NumPy, scikit-learn, and Matplotlib. And now you know the basic understanding of these three libraries. And I hope you have got a basic understanding of Jupyter notebooks as well. Now what I'll be demonstrating is how to basically integrate all of these packages in VS Code. So if you have downloaded Python and if you have integrated it with VS Code, like I showed you in the first lecture, you will be able to execute a simple hello world command. But if you want to do array manipulations, or if you want to run a machine learning algorithm, or if you want to plot something, you need to load the libraries which I just showed you. You need to load the libraries such as NumPy, scikit-learn, and Matplotlib. And to load the libraries in the first place, we need to initially install them. So let us go ahead and install these libraries. The installation instruction for these libraries is extremely simple. It's just one sentence and it's mentioned in the description pages. So if you go to scikit-learn and go to install, it says that you just have to type this particular command. One very important distinction is that instead of using pip, we will be using pip3, because ours is the latest version of Python. So this pip command won't run on your command line interface, which I'm just going to show you. So just replace it with pip3. We'll be using a similar command for installing NumPy as well as Matplotlib. So let's initially start with NumPy, then go to Matplotlib, then let's go to scikit-learn. So to install NumPy, the first thing to do is, let's say you have created a folder, and in this folder there is your different code files which you have. If you have not created a folder, please go to this folder icon which I'm highlighting right now, and you can create a sample folder. So I'll just show you right now how to create it, then I'll delete it. So right now I'm creating a sample folder. That's it. So let me delete this right now because I do not need this. Delete. Okay, so the way to install these packages is go to the folder which you have created, right click and click on open in integrated terminal. These same commands will work for Mac as well as Windows. So all you have to type is pip3. So if you type pip install numpy, it will give you an error if you have installed the latest version of Python. So type pip3 install numpy. So I have already installed NumPy, so it will show requirement satisfied, and then click enter. So here it tells me that requirement already satisfied. I have already installed this package. If you have not installed this package, it will take some time. It took around 1 minute for me to install this particular library on my device. So that's it. With just one command, we have installed NumPy on our local machine. Now let us install Matplotlib. So to install Matplotlib, I am going to type pip3 install Matplotlib. Even here you can see that requirements are already satisfied. This is because I have already installed the package or the library. You will need to wait for some time till the Matplotlib package is installed. And the third thing which you will have to do is installing the third package, which is scikit-learn. For scikit-learn, the command is a bit different. So I suggest that you go to this website or just type on Google install scikit-learn. it will take you to this place. Click on the install folder and then look at the first command. So copy this and paste it in your command line. Let me go to the command line again so that you can have a clearer view. So I've typed this right now. The thing which I mentioned earlier is that if you just execute this, this will show an error. So you need to replace this with pip3 and then let me run it. So here also we can see that the requirements are already satisfied. For scikit library, it takes a bit of time to install because it is installing so many machine learning functions, internal packages, etc. So you might need to wait for 2.5 minutes, but it should generally install fairly quickly. So right now what we have done is that we have installed three packages. We have installed, or three libraries. We have installed NumPy, we have installed Matplotlib, and thirdly we have installed scikit-learn. Now let us do the very important thing of integrating Jupyter Notebook with VS Code. Ultimately, we are going to run the Jupyter Notebook also in the VS Code interface so that it stays on your local system. So first we need to install Jupyter, and that has to be done in a very similar way to what we did for the other packages. So let me go to open in integrated terminal and let me type pip3 install Jupyter. So here also we can see that requirements are already satisfied for me. Requirements already satisfied because I have already installed it. For you, it may take some time again to similarly install Jupyter Notebook. That's it. So for each of these packages, for Jupyter, for scikit-learn, for NumPy, and for Matplotlib, we just had one command, and in just one command, that particular package is installed on VS Code. In order to configure Jupyter Notebook on VS Code, one more thing which you will need to do is go to the extension or VS Code extension, which is given by this symbol here, this square symbol, and then type Jupyter. When you type Jupyter in the extension, what you will notice is the first thing which shows up, it has around a huge number of installs. So you can click install here. It's showing uninstall for me because I've already installed it. And this actually takes some time. It takes 2 to 2 minutes. I was hoping that this installs immediately, but don't be concerned if it's taking time. It usually takes this much amount of time by default. So once the Jupyter extension is installed on VS Code, you are now ready to run a Jupyter notebook on VS Code. So let me actually show you how. In your folder which you have, go to this symbol for creating a new file. And you see other files have a .py extension. Jupyter notebooks have a different extension. They have an extension of IPYNB, which is like Python notebook. So IPYNB is like, I think, interactive Python notebook. That's why it is IPYNB. So every Jupyter notebook file should have this extension. Extension. So let me type here sample.ipynb. So this, when you create this file, it immediately brings you to another interface like this. .py files have a different interface. So right now I'm in a .py file, right? But if you type .ipynb, you are immediately taken to an interface which looks quite different. And the first thing to notice in this interface is that here it gives you an option to select kernel. So you can click on the select kernel and click on the Python 3.12.2, which you have already installed, which means now the Jupyter notebook is connected to the Python kernel. If you have Julia language or other languages installed, you can connect it to those languages. But for the purposes of this entire series, we are going to do the entire coding in Python. So that's why I have integrated this notebook with the Python kernel. One more thing to notice is that there are two options on the top. There is a code option and there is a markdown option. Let me show you both these options. If I click on markdown, uh, let me delete this. Let me delete everything. So if I click on markdown, a cell opens up. So the place where you type is called a cell. That cell can have two types: markdown, which is just a text, and code, which is like a code which you are planning to write. So here I'm writing, this is my first Jupyter Notebook. And then we can click on the then you can either press shift plus enter. If you press shift and enter, that particular cell is run. One more thing which you can do is click on run all. This also runs that particular cell. The best way generally I find or I use to execute that cell is press shift and return. So I press shift and return right now, and that particular cell is run. Here you see why it is called as markdown. It is called as markdown because this looks like a normal text. It's not a code. If I want to write a code, let me go to this thing and let me type print hello world. So this is a code. And one more way to execute a code file is, of course you can, or a code cell is, of course you can press shift and return, which will execute this code cell. Or you can press the small arrow here. Here you can see a small right side arrow which appears pointing to the right. You can press here, and here you can see that the code is running, and now the code is fully run and the print is also shown. So you can see this is much better than the .py files, right? Because here what I needed to do was I needed to open my command line. So if I did not have the Jupyter notebook, what I would have done is that I would have executed it here, and then the output would have been shown in the command line. That is so cumbersome. Now what I can do is I can just close all of this, go to the sample.ipynb notebook, write the code. I can write the code and execute it here itself. So the output is shown here itself. And not just that, I can do several other things. Like here you can see, here I have just written text. I can even write some document information. One more thing is that instead of pressing this plus code or plus markdown each time, you can just hover over below the most recent output, and here it again shows these two options. So let me click on the markdown, and we can even write sample paragraphs here. So let me copy paste something from maybe the Jupyter's thing itself, and just paste it. Great. So these are not codes, right? But these are sample paragraphs. So this also we can write here. Here you can see this is now executed. So this is a sample paragraph. I can easily, as a tutor or a teacher of machine learning, using Jupyter Notebook, I can easily create a tutorial like this. I can say that, let me go to Markdown first, run this below cell. And then I click on this correct tick button. So this is executed. Then I show the code, and then I prompt the user to run the code, and then I write congrats. This is your first hello world code. So here you see I made a mistake of not changing it to code format. So let me delete this. Sorry, not changing it to markdown format. It was in a code format. So I click on the markdown and I enter this text and I run this text again. So here you can see now this is run. It's very easy to create tutorials like this which mix text with coding blocks. I can even add images in the Jupyter Notebook environment. So that makes it very easy to use Jupyter Notebook for communication. Remember, I told you one word which I associate with Jupyter Notebook, and that's communication. And now I have demonstrated practically how you can write text, inter or have code blocks, then write text again. Later, you can even add images. Basically, the whole thing can be made much better for communication instead of just these .py files. This is the advantage of having Jupyter notebooks, and I'll be showing the random linear classifier coding which we are about to do now in the Jupyter notebook itself. So I hope everyone has reached with me up till this particular point, and in this lecture we learned about two things. We learned about Jupyter notebooks. We learned why they are useful. We learned how they can be used for communication. We also saw how to integrate Jupyter notebooks with VS Code. Second thing we learned is three very powerful Python libraries: NumPy, scikit-learn, and Matplotlib. And we saw that each of these serves a different purpose. NumPy is for scientific computing, scikit-learn is for machine learning, and Matplotlib is for plotting in Python. We also saw that to install NumPy, scikit-learn, and Matplotlib, there is just one line of code which is needed. And to install Jupyter Notebook also, there is one line of code. Further, we saw that Jupyter Notebooks require a .ipynb .ipynb extension. Like here, we created the sample.ipynb file. We saw that we need to link the notebook to the kernel, which is Python. We also saw about two options: code and the markdown. Markdown is when we want to write simple text, and code is where we actually want to write the code file. We also saw how to execute different code blocks or code cells. For coding, for if you have written a code, we just press on the arrow here or press on shift plus enter. To execute the markdown files, again we press shift plus enter, or we click on this plus symbol over here, which will render that particular code block or that particular code cell. So this brings us to the end of this particular lecture. If you have followed up till now, please stay around for the next lecture, because in the next lecture we are going to run the random linear classifier algorithm in Python. If you have not been through the linear classification lectures, please go through them. I'll introduce the problem again in the next lecture. But in the next lecture, we will be coding the algorithm in Python. We will be seeing and visualizing the results, and we will also understand the importance of training, testing, and validation data through the code itself. I hope you learnt about Jupyter, NumPy, scikit-learn, and Matplotlib in this particular lecture. Please ask in the comments if you have any doubts or any questions. I'll try my best to clarify them. And please stick with me throughout the courses of this series. Try to install Python, try to get comfortable with these libraries. As you saw, it's very easy. With just one click you can install all these libraries and have the power of Python on your local machine so easily. So don't be afraid of these terminologies like Jupyter, scikit-learn, etc. It's quite simple. That's the main objective of this lecture. Thank you so much, and I'll see you in the next lecture.